Hello, welcome to Simulations in Education. Our objective today will be to look as instructional design students how simulations can improve educational platforms, delivery systems in the classroom, and finally, viewing key benefits from a developer's perspective. So let's get started.
Simulators have been around for decades. In 1929, the first commercial simulator was built for aviation. This simulator saved thousands of dollars in costs to train pilots on how to properly take off, fly, and land aircraft. This was not the only type of simulator that was used since the 1920s. We have had simulators in the fields of medicine, military training, business management, science, and many other comparable.
Now that we saw how simulations got started, now let's see how it's defined.
Simulation is the imitation of the operation of a real-world process or system over time. The act of simulating something first requires that a model be developed. This model represents the key characteristics or behaviors/functions of the selected physical or abstract system or process. The model represents the system itself, whereas the simulation represents the operation of the system over time. Simulation is used in many contexts, such as simulation of technology for performance optimization, safety engineering, testing, training, education, and video games. Often, computer experiments are used to study simulation models. Simulation is also used with scientific modeling of natural systems or human systems to gain insight into their functioning. Simulation can be used to show the eventual real effects of alternative conditions and courses of action. Simulation is also used when the real system cannot be engaged, because it may not be accessible, or it may be dangerous or unacceptable to engage, or it is being designed but not yet built, or it may simply not exist. Key issues in simulation include acquisition of valid source information about the relevant selection of key characteristics and behaviors, the use of simplifying approximations and assumptions within the simulation, and fidelity and validity of the simulation outcomes. Procedures and protocols for model verification and validation are an ongoing field of academic study, refinement, research and development in simulations technology or practice, particularly in the field of computer simulation. Historically, simulations used in different fields developed largely independently, but 20th-century studies of systems theory and cybernetics combined with spreading use of computers across all those fields have led to some unification and a more systematic view of the concept. Physical simulation refers to simulation in which physical objects are substituted for the real thing. Some circles use the term for computer simulations modeling selected laws of physics, but this article does not. These physical objects are often chosen because they are smaller or cheaper than the actual object or system. Interactive simulation is a special kind of physical simulation, often referred to as a human-in-the-loop simulation, in which physical simulations include human operators, such as in a flight simulator or a driving simulator. Human-in-the-loop simulations can include a computer simulation as a so-called synthetic environment. Simulation and failure analysis refers to simulation in which we create environments/conditions to identify the cause of equipment failure. This was the best and fastest method to identify the failure cause.
Bring real-life scenarios to the classroom. Not only in aviation and medicine can we leverage the benefits. Simulations can be used in many areas of education such as science, history, mathematics, and geography. The benefits and cost savings of additional facility space or travel would benefit students. Now let's take 2 minutes to answer the following questions. As an instructional designer, How would you incorporate simulations into your training? What tools are already available that can be used as simulators to enhance current training? Should simulators be used as evaluation tools? Congratulations, you've completed your training. In summary, as instructional designers, we need to find new ways of incorporating as many tools as possible to create a better learning environment. Simulations reinforce previous training and provide knowledge that will replicate the equipment's operation to reduce the number of hours it would take to cycle individuals through equipment. They can also reduce the cost of equipment maintenance and quality for technical training. These are the tools that we can leverage to make our lessons and curriculum better.